Hello friends, welcome to the next session. Now we are going to complete the last problem of type 2 of finite state machine. Let's get started. This problem is ideally going to be a sub part of the previous problem itself. So let's get to the question. So the question over here says, design a FSM in which the input is valid if it contains exactly 3 A's over the alphabet AB. The previous question was saying at least 3 A's. Now it is saying it contains exactly 3 A's. The two questions are really very similar. And of course, the problem solving approach to this is also going to be the same. So when I say, how are we going to solve the problem? The simple solution is whatever you can see right now on your page will exactly be the solution for this problem with a very small difference. Now, what is that small difference going to be? If you observe what is solved, I can see over here that I have not marked any of the states as a final state. That's what is going to be the only change in the problem. So my question over here says it has to be exactly 3 A's, and which is the state if I observe among QS, Q0, Q1, Q2, Q3, Q4, keeping a track of exactly 3 A's. Yes, you guessed it right. It is only state Q3. Therefore, over here we say the final state for this problem is going to be my state Q3. Right? So you can mark a star for the state Q3. Rest all are going to be non-final states. Let's start with the example. So if I consider the example QS A as a string, we all know that this example should be accepted. So let's go ahead. Now there is one more change that you should understand. The machine function which we have currently shown on the screen was a machine function for the previous problem. Now the only change in the machine function will be I'll be having Y's marked in those cells where I find state Q3 and not Q4. So right now I can see that Q4 is associated with the output yes over here and yes over here. Now these all will be marked as no. So for convenience, you can prepare your own machine function. So now if you observe this problem, QS on receiving input symbol A is going to Q1, input left is BAA. Q1 on receiving input symbol B is going to Q1 only. So I say it is remaining in the same state with the input as AA. Q1 on receiving input symbol A goes to Q2. So I have Q2 followed by single A, and lastly Q2 on receiving an input symbol A goes to Q3, and we know that Q3 is the final state and therefore the output thrown by the final state is always yes. So this input will be accepted because the number of A's in A is exactly 3. Moving to the next problem of the reject case. So the example over here says I have QS on receiving BA as the input. So number of A's are not 3, they are actually lesser than 3. Similarly, you can solve a problem where the number of A's are more than 3 and you can yourself see that it will be rejected because the final state is not Q3. So if you observe this problem, QS on receiving B goes to Q0 with ABA left on the tape. Q0 on receiving A goes to Q1 with BA left on the tape. Q1 on B remains in Q1. So I have Q1A, and lastly Q1 on A goes to Q2, and Q2 is not the final state, therefore the output is going to be no. So with this we complete this problem. See you in the next problem. Thank you.